I am Wesley, and I was doing a project on deep learning classification for breast cancer uh, using CNN. My problem statement, or some of the problems that I was trying to solve, is the problem of manual examination of pathological images, subjective interpretation due to clinician fatigue, global shortage of the qualified pathologists, which results in turnaround times and delayed clinical interventions, diagnostic delays and inaccuracy, which are directly correlated with the advanced disease progression and significantly diminish patient survival. Uh, for my objectives, so the main objective was to develop and evaluate a CNN deep learning model for automated binary classification of invasive ductal carcinoma. So for my specific objectives, I was to pre-process the breast histopathology images through resizing, augmentation, and dataset splitting for robust model training. It was also to implement a ResNet-based CNN using transfer learning for binary classification of a IDC. I was also to train and evaluate a model using cross-validation and metrics like accuracy, precision, recall, F1 score, and ROC-AUC. I was also to apply GradCam for model interpretability, highlighting histological features like nuclear pleomorphism influencing predictions. Yeah, that was for my objectives. So uh, let's move ahead. The model. I obtained my dataset from Cargo, yeah, and it contained a total of 279 patients, and it contained a total of 198,738 negative samples and 78,000 positive samples. So uh, I added a penalty which will maximize on the minority class. Uh, um, I added a penalty to maximize on the minority class since uh, it was the underrepresented sample in this data set. So I transformed the images through horizontal flipping, random rotation, and transforming to tensor that basically between a range of 0 to 1. And I also normalized the images. I used a batch size of 32, and I was using the ResNet 50 pre-trained model. So I trained the model uh, in a total of 10 airports. And it had an accuracy of 84% and an ROC-AUC score of 0.90, which basically means that it's good at differentiating between the negative and the positive image sample of the IDC cancer image. So this is the confusion matrix. Uh, from this ROC curve, we can see that it's leaning more to the left, which means that the model is performing better and more values are for the true positive. You can see more values are across at once, so that means the model was performing good. Uh, and for the random classifier line, that line is used to show any model that has an ROC that goes in such a manner. Uh, it means that the model was so random and it was not able to capture the patterns. And this is the GradCam visualization. Yeah, it's able to show the heat maps. For this, we can see that this is a negative sample of an image and it's predicted negative. So it's used to, so from the GradCam visualization, so the red parts are used to show the parts that played a key role in predicting this image as negative. So from red to yellow, red is the most important in that played the most important role, then followed by yellow, and then this other color, purple. Yeah, it did not play a role in predicting the image. So this is grad come from for explainability. So I saved the model, and the model had a size of 90 MBs. Um, I deployed my model on Hugging Face, containerized the PyTorch and PyTorch and the TensorFlow using Docker. And I did for my front end, I used TypeScript. For my back end, I used Fast API. And for hosting front end, I used Vercel. For back end, I used Render. So I use containerization because the model used to take a long time to pre-process the images. So Docker, in using Docker, the TensorFlow and the PyTorch libraries are released to render so that they can process the images, reducing the waiting time. So we can only create a patient's account. So let's go with Ronnie Dev. So we create a patient account. So you'll be able to upload uh, a tissue image here for the patient. So we run AI screening so that the model can be able to predict the class of the image. So we can see that uh, the model has predicted this image to have a 97% confidence of being negative. So we'll go to the dashboard and we see that it's updated. So I sign out. So let's log into the admin portal. So for the pathologist and the admin accounts, they can only be created by the admin for safety purposes. So we see that Ronnie Dave is not assigned a pathologist, so we come here and we assign Dr. Gordon to Ronnie and we save. So I sign out again. I go to the pathologist, I log into the pathologist account. So you can see the case here. So mm, basically, the people who do screening of the tissue images are the radiologists. So after screening the image, they give you upload a sample, yeah, to the model. So they remain with the with the tissue image, which is then given to the pathologist. So if AI has predicted you to be negative, uh, negative. So because this is in the medical context, we cannot fully rely on the predicted predicted models. It's just we are doing this to be able to identify the most endangered patients in terms of being positive or negative for breast cancer. So if predicted positive, uh, the whichever the prediction, and if you want further confirmation, the pathologist will be able to do a review of the uh, tissue, and then he'll be able to tell you if the AI predictions were right according to them, or if they were inconclusive and further staining is required. So they'll uh, add some notes for you. And they'll finalize and send the report. So this is how the report looks like. So uh, since we had assigned uh, this doctor to Ronnie Dave, they can be able to text directly via their portal, to text the patient directly via their portal. So let's go to the patient portal and see if the image and the review have reflected back. So we can see that it is reviewed, and the patient will also be able to download the report on their side. Uh, the patient will also be able to text back, uh, to text the doctor back via their portal. So with this, the pathologist will be able to get the message on their side. So this was my project. Thank you very much for your time.